Validation is used to validate the freshness of a response that has been cached. When a cache has a stale entry that it would like to use as a response to a client's request, it first has to check with the origin server or possibly an intermediate cache with a fresh response to see if its cached entry is still usable. But to be able to validate, we need something to, validate against. And that's a validator. These validators are used to check if they represent the same or different responses. There's two types of validators. A strong validator changes if the body or headers of a response change. A typical example of such a validator is an E tag, which means entity tag, sent through the E tag response header. An E tag is an opaque identifier assigned by a web server to a specific version of a resource. Strong validators can be used in any context, with caching, but also for concurrency checks when updating resources, as we will learn later on in this course. They guarantee equality. A weak validator, on the other hand, doesn't always change when the resource changes. It's up to the server to decide when a change is warranted. For example, the server can choose to only change it on significant changes and not when less significant aspects change. A typical example is the last modified response header, containing the time when the resource was last modified. These are implicitly weak. We've got a possible 1-second gap. Now, it is possible to make these strong by adhering to a set of rules, like an additional date value on a cached entry that's at least 60 seconds after the last modified time, but that would lead us too far. So we're going to treat these as weak. But whether you make this strong or weak, the clocks still must be synchronized for this to work, so it suffers the same issues as the expires header. That is why E-tags are a better option. And if you need it, there is something like a weak E-tag as well. When it's prefixed with W/, it's treated as being weak. It is up to the server to decide this. When an entity tag is in this format, it doesn't necessarily change if the response changes. Weak validators can only be used when an equivalent resource is good enough, but equality isn't required. In other words, when you don't always need the most recent version. Simple GET requests for caching, for example, are allowed. They can be even more efficient if an equivalent version would be okay for a client, but anything else isn't. We cannot use these if we need to be sure that different versions are equal, nor for concurrency checking. In other words, in case of a resource we can get as well as update, a weak tag is a bad idea. The HTTP standard advises to send both E tags and last modified headers if possible. But this immediately poses a problem for us. The response caching attribute does not support E tags, so we cannot use the best practice when working with that attribute. In the next module, we will learn about a different approach that does allow working with E tags. For now, let's have a look at how the validation model works. We've again got a client application, a cache which can be shared or private, and our API. The application sends a request to get the authors. The request hits the cache. There is no cached version of the response available, so the cache forwards the request to our API. Our API returns a response that includes an E tag and a last modified header. That is sent to the cache again, which forwards it to the consuming application, but at the same time stores a copy of this response. After that, the client app sends a request to get the author's resource again, 10 minutes later. We hit the cache, but we cannot be sure that the response that has been cached is still fresh. There are no cache control headers to check for this in our example. So the cache has to check this with the origin, our API. It does this by adding request headers, if non-match, set to the e-tag value, and if modified since, which is set to the last modified value of the cached response. These make this request conditional. The server receives this request, and it checks these headers against the validators it holds or generates for that request. If this checks out, the server does not have to generate a response. It sends back a 304 not modified, after which the cache can return the cached response with the original last modified header if it supports last modified. If the resource has been modified, the API will, of course, have to generate a new response. If this is a private cache, that is again where it stops. But if we assume that this cache is a shared cache, a subsequent request from another instance of our client application 10 minutes later, or from another client application that consumes the API, will hit that cache. The cache will set the if modified since header to the last modified value of the cached response, and if non-match to the e-tag value. If it still checks out, the response still does not have to be generated. In other words, with validation, the same response only has to be generated once. If it's a private cache, subsequent request, save bandwidth. We have to communicate with the API, but we don't need to send over the full response from the API. Only a 304 not modified if the response is the same. If it's a shared cache, subsequent requests don't save bandwidth between the cache and the client, but it does save bandwidth between the cache and the API, as the API doesn't have to regenerate a response if it's still valid, so it doesn't have to send over a response body to the cache. In contrast to the expiration model, the validation model is not correctly supported by the response cache attribute and response caching middleware. But don't worry, we will look into a solution in the next module. So, two different strategies, two different uses. Ideally, expiration and validation are combined. Let's have a look at what that looks like. And let's immediately make the separation between private and shared caches. Let's start with the private cache. We've got a response to our author's resource cache. It has a cache control header for expiration checks and a last modified and e-tag header for validation checks. A new request is sent, and as long as the response hasn't expired, the cached response can be used. This reduces communication with the API, including the regenerating of responses, and it also reduces bandwidth requirements. We don't even hit the API, and as you remember, the private cache lives at level of the client. Once the response expires, we do hit the API. If we only have expiration checks, this means that the API would have to regenerate the response. But if we additionally have validation in place, we can potentially avoid this, because it's not because a response is stale that it is invalid. So, the API checks the validators, and if the response is still valid, sends back a 304 not modified. In other words, bandwidth usage and response generation are potentially reduced even more. Because even an expired response doesn't necessarily result in the response having to be regenerated and resent to the cache with a response body. If the cache is shared, the cached response is used as long as it hasn't expired. This doesn't reduce bandwidth between client and cache, but it does result in bandwidth reduction between cache and API, and it dramatically reduces the amount of requests to the API. A lot more than a private cache, as this one is shared across potentially unlimited client instances. If the response expires, the cache must communicate with the API. But here as well, that does not mean that the response has to be regenerated. If validation checks out, a 304 not modified is sent to the cache without a response body. That potentially reduces bandwidth usage between cache and API, and potentially reduces response body generated. The new response must still be sent from the cache to the client, of course. Combine these two, a private cache for each client instance and a shared cache at server level, both with expiration and validation models in place, and we reach the holy grail of caching. That's it for the expiration and validation models. There's one more thing we have to cover before we get into the next module to learn how to work with the validation model and e-tags. As we learned a bit earlier, there's a few cache control directives available that control caching, both at request side and at response side. Let's have a look at those.